Hi everyone. So this is the robot that I'm working on at the moment, and I've basically followed the build of Dronebot Workshop for the first part of the robot, which is the frame and the motors, and then I'm going to converge with attaching the electronics because I'm using ESP32s and Bill was using Arduinos, but I'll just give you a quick overview. So I've attached this piece of perspex to the top, just with a couple of like long screws with these spacers on them, and I'm using two 12-volt DC motors. So it's pretty much almost exactly the same as the first part of Bill's build on Dronebot db1, and then I've got these buck boost converters here for the 12-volt and the 5-volt. And 12-volt is off the green wires and the 5-volt is off the red wires. And I've wired all that up to the top through these connectors and through these rails here. So this is the earth rail, this is the 5-volt rail, and that there is the 12-volt rail. So let's have a look at the top shelf, or the one I just pulled off, and how that's going to be set up, which is actually going to be the middle shelf. And I'll show you how I'm going to connect the electronics. Thank you. Hi everyone, so this is the platform, the perspex platform that's going to go on the robot. And I've just got all the electronics here, and I'm just going to go through all of those with you. So these are the motor controllers. These are cytron MD10C R3 motor controllers. And I've got two of those, one for each motor. And they're capable of delivering quite a fair amount of current. And then I've got an ESP32, which is going to be used to connect to the motor controllers. And the reason I'm using the ESP32, so this is where I converge with Bill's build. So Bill uses Arduinos in his db1, and I'm using ESP32, and there's a few reasons I'm doing that. I guess the obvious reason is because there's Wi-Fi and Bluetooth, and also if I've got a lot of boards on the robot, I can connect them all together through ESP now. But another reason why I've chosen to do these boards is because I can use a real-time operating system. So the RTOS I can use for running commands for the robot, which I think is a bit more intuitive for an autonomous machine. So we'll see how that goes. And then I've got some ESP32 dash cams, one for the front and one for the back, and a couple of fuses for the motor, because like I said, these controllers are capable of delivering quite a fair amount of current, and the motors I've got have a 10 amp stall current, and I think these can deliver up to about 30 amps, but I'll have to check that. All right, so I'm going to wire all that together and we'll see how that goes. Hi everyone, so these motor controllers have got these screw terminals on them, and putting the wires in the screw terminals, it doesn't really work very well unless you've got solid core wires, because what happens is the end of these wires here, they kind of squash down, they become really squashed and they come out quite easily. So to avoid that, I'm going to just put on a lug on the end of the wire like this, and I'm just going to use this lug, and I'm going to fold these two forks over, so it's just going to make one point, and that's going to go in the screw terminal much more easily. Hi everyone, so I've done the wiring now for the robot just to get it driving. So on the top level of the robot, I've got some batteries here, some 1860-50 cells, just because the reason I've got those batteries is because when both motors start at once and they pull current out of the bigger battery here, it crashes some of the electronics, so I have to power the ESP32 with a separate battery. And I've got my cytron MD10C motor controllers up here as well. And then everything here, I'm I'm going to put a few more sensors and stuff connected to the ESP32, but everything here is connected to the base with these 2.8mm connectors, and these are pretty good. You can just find these on Amazon or AliExpress, and they just kind of plug in like that, but you have to plug them in the right way around, which is pretty good. And then I've got these ones here connected to the motors, and this one here is connected to the power. So so I can lift this off now, which makes it easier to work on the underneath the robot. And under here I've got my battery, which is connected to this buck boost converter, which is converting it from, I think, about 14 volts to, this is a LiFePO, to about 12 volts. And then I had that as well going into another buck boost converter, converting to 5 volts, but that didn't actually work. This kept crashing when I started the motors, and I tried a couple of different ways, and it's just, I think, because there's a large current draw from this battery when both motors start. So that's why I had to use the separate 18650. And then I've got a switch down here, which I just got off Amazon actually, and I think it's supposed to be for a boat. So it just comes up there, and then you can switch it on, and then you can just push this plastic bit and it'll switch it off. So it's quite good. And I've got some bus bars just for the power, so that's for the earth. That one there's for the 12 volt, and then there should be one more around this one here, which is supposed to be for the 5 volt, but I'm not using that anymore. And then the motors are Yellow Jack 5202, Yellow Jacket 5202 series. So it's working pretty well. So I'm going to put the top back on and we can see it in action. So I've connected the top now, and I've plugged everything in here and here, so the motors and the power, and then I'll just say I put these fuses in, which go directly to the motors. So these are 10 amp fast blow fuses, and I put one of those on my power supply, my benchtop power supply, to see if it would actually blow up, but it doesn't blow up when it fuses. It just disconnects and stops working quietly, so no big explosions there. Also, I've got these are the motor encoders for the these motors come with motor encoders, and these are quadrature encoders, so it's ground, 5 volt, and then a channel A and channel B encoder. And I'll show you the controls as well, the ones that are coming from the ESP32 onto the Wi-Fi. And so far, I mean, it's just really like a glorified remote control car. So these are the controls here. So I can go, I'll show you the wheel, and I can press left and the wheels will spin in the opposite direction, forward, reverse, right, stop, and I can increase the speed as well. So it can go pretty fast actually. Yeah, so that's almost full speed there. So these motors are actually pretty quick. Alright, thank you. Well, I'll take it down now and we'll have a look and see how it goes on the ground. So I've attached a couple of ESP32 cams to the robot as well. So I've got one here at the front and one here at the back, and I'll show you how that works next. But the other thing I've got here is I've got this like a USB breakout board, which I've got connected to this battery here. I think I'm going to have to upgrade that at some point to a power pack. And then this ESP32, I've got an aerial attached to this, but this one doesn't have an aerial attached yet. I'm going to attach that next. So let's get moving. So these are the controls that I've set up for my robot, db1.5, and these are the direction buttons: forward, left, right, reverse, forward, right, and this shows the output from the camera here, and then there's a giant stop button, of course, which I guess is kind of my way of putting an emergency stop on there. And this is the robot speed down here on this slider, and the output of the camera is shown here, so I can do the front camera or the rear camera. And the reason I've put them, I've used a switch rather than have them next to each other, which I had originally. I had the front and the rear next to each other on the screen, is because it gets a bit cluttered on the screen, especially if I'm trying to control it with my phone or something. So the way I've done that is I've connected the ESP32 cams to a static IP, and then I've hard coded that IP in the JavaScript file. So we can move it forward by pressing this forward button, stop, and then reverse, stop, and we can see the camera shakes a little bit when we're moving. We can look at the rear so we can see that Tonka truck. Reverse and forward, and then it stops shaking once it stops. And the way I've implemented this is with a WebSocket, and the reason I've implemented it with a WebSocket is well, one, it's faster, and two, I can have it on two different screens or two different devices, so I can have it on my computer as well as on my iPhone or my tablet. So just have a look here. So this is on a second screen now, so I can look at different camera angles if I've got it up on different screens. And now what happens is when I update the screen, it goes to both screens, but everything updates on both screens except for the camera. And I've set it up like that just so I can have two screens up and look at two different cameras if I want to. So if we press the forward button on the left, it'll change on both the left and the right. And there it crashed, knocked something over. Okay, so front, rear, let's reverse, stop, and now the camera comes back into focus. And the code I've written for this, I'll put that up on GitHub, and I'll try to see if I can make a separate video on that, because there's a fair bit of it. But I'll link to the GitHub repository in the description. So, and if you've got any questions or comments, just put them down below. And the next thing I'm going to do for the next episode, I'm going to add a few more things to the robot, and I'll show you that now. Thank you. Okay, hi everyone. So I'm just going to discuss the next steps now with this robot. So the first thing I'm going to do is connect these are the encoders which connect straight into the motor, and these are quadrature encoders, so I can I think there's probably about 700 pulses per revolution, and I can use these to measure the speed and the distance that the robot is traveling to get a bit more data. And also I'm going to put some lights in. So I've got these are addressable LEDs which I'm going to put around the robot. So these will just change colour depending upon which direction it's going and stuff, and also make it look a little good as well. And a touch screen. I've got a TFT touch screen which I'll use just for input and displaying data and stuff from the robot. And so to get all this in, I'm probably going to have to put in another board. So I'm going to have another ESP32 on the robot, which is going to be connected to the lights and the touch screen. And I think I'll connect the encoders to the one that's already connected to the motor, because I'll have all the motor stuff then connected to one board, and then the lights and the touch screen connected to this board, and I'll have the two boards communicating via ESP32 now. And then on the bottom of the board, I'm going to put some of these. These are just some ultrasonic sensors, some distance sensors, so just to stop me from crashing into things. And this one here, I've printed this up, so that's at 15 degrees, so this is going to be facing downwards, and then it's going to, just so the robot doesn't go over a step. And then I've also printed these brackets as well, so I can watch in front and at 45 degrees. And I'm going to attach these down to the bottom rail here, and I'll also have another board, or maybe two boards, one for left and one for right on the bottom layer of the robot, just to get data from those sensors. And I'll also have these boards connected with ESP32 now. So hopefully if I once I've got all that connected, I can then implement some goal-seeking behavior on the robot. And so I'll connect all that, and that'll be ready for the next video. So we'll see how that goes. Thank you very much.